Hello everyone, welcome to my channel Chemistry by ANR. Today's topic is concentration of solution. Regarding binary solution, we have already discussed in the previous session where I said that if a solution contains two components, it is known as a binary solution. Now, these two components are solute and solvent. So, conventionally, if we assume that solvent is A and solute is B, and we have taken two solutions in beakers 1 and 2, where we are assuming the concentration in beaker 1 is C1 and the concentration of the solution in beaker 2 is C2. And we are assuming that the amount of solute in second beaker is B2 and the amount of solute in the first beaker is B1 such that B2 is greater than B1. In this case, we can understand that the amount of solute present in beaker second is greater than the amount of solute that is present in the first beaker. So, the second beaker is a more concentrated solution it is having than the first beaker. So, we can say C2 is greater than C1 as per the concentration of solution concept. Next, here we can see concentration terms. If I say solid in liquid, solutions can be of many types. Now, if I take solid solute and say liquid solvent, and I said B is solute and A is as per convention solvent. Suppose we take this and solid solute in liquid solvent, then also what is the concentration of a solution? It is the mass of solute in gram present in 100 gram of the solution. Okay, so if I say it is a 10% solution of NaCl, then it clearly means that the mass of NaCl over here is 10 gram. If the mass of the solution is actually 100 gram, then the mass of the NaCl, that is solute, is 10 gram. So what should be the mass of solvent then? The mass of the solvent should be the total mass of the solution minus the mass of the solute. So the mass of the solvent is equal to 90 gram. So we can understand that 10 gram and 90 gram actually makes up the mass of the solution, which is 100 gram. Okay. So concentration of solution can be expressed as mass percentage. Okay. So concentration of solution can be expressed as mass percentage or percent mass. It is expressed as percent mass. What does it mean? Percent mass actually means, suppose I say mass is W, mass of solute divided by mass of the solution, WB plus WA, into 100. That means in 100 part of the solution, what part of the solute is present? If the total mass of the solution is WA plus WB, this is the total mass of the solution, then the concentration term will be the mass of solute divided by the mass of the solution into 100. So this is the concentration term in percent mass. Suppose a solution contains 30 gram of sugar dissolved in 370 gram of water. How much? Say I take 30 gram of sugar. Sugar I am taking, so obviously solute is sugar. So I will take WB. WB means mass of the solute is equal to 30 gram is taken in 370 gram of water. So mass of solvent is equal to 370 gram. Calculate the concentration of the solution. So what can we do? Concentration of solution, it is given in mass. So concentration of solution means how much of the solute is present in fixed mass of the solution. So it will be 30 divided by mass of solution will be mass of solvent plus mass of solute. Okay, so 370 gram of water is taken. So over here I will say mass of solute plus mass of solvent is the total mass of the solution into 100. When we do this, we will get the mass percent. Next question says if 110 gram, this was one question, okay? This was the first question. Next, if I say if 110 gram of copper sulfate is present in 550 gram of solution, calculate the concentration of the solution. So it is given in mass. Obviously the concentration of solution is actually in mass percent. So this will be again the mass of the solute divided by mass of solution into 100. Now over here, as per the data, mass of solute copper sulfate is given 110 divided by, now here mass of the solution is totally given, not the mass of the solvent. So 550 gram is actually mass of the solution. So you have to read the statement carefully, whether it is given just the mass of water or it is given mass of solution. This is mass of solution. So this into 100, this value will be the concentration of copper sulfate solution. Now, in the case of liquid, say liquid solution, that means my solute is liquid and my solvent is also a liquid. In this case of the solution, again I am telling you that A is chosen as the solvent and B is chosen as the solute. So for such a solution, what we are going to do, the concentration of the solution is defined as the volume of solute in milliliter. So here in this case, concentration of solution is taken as volume of solute in ml. Okay, in ml divided by volume of solution in ml, of course in ml, okay, into 100. So if you have to place it or express it in percentage, we are going to do it in this manner. So let us see application of this question. So here it is saying that a solution contains 50 ml of alcohol mixed in 150 ml of water. So here I can say mass of alcohol, that means WB, is equal to 50 ml and mass of water is equal to 150 ml. So we can say mass of the solution is equal to mass of solute plus mass of solvent. So 50 plus 150 ml. So this comes out to be 200 ml as the mass of the solution. So what is the concentration of the solution? Since both are in the liquid phase, we will say concentration of solution will be equal to the volume of the solute, which is equal to 50, divided by total volume of the solution, which is equal to 200, of course into 100, because it is expressed in percentage. So this is it. So let's see the next. It says if 2 ml of acetone, acetone is again an organic material, organic compound. Acetone is CH3, C double bonded O, CH3. So if you can remember, it is good. If you don't remember, you will get opportunities later on to come across this type of compound. This is acetone. It is also known as propanone, and it is actually a ketone. Okay, so it is actually a ketone. So 2 ml of acetone. This is acetone is my solute. So VB is the volume of acetone, that is 2 ml in 450 ml of aqueous solution. That means volume of the solution is equal to 4 it is 45. It's 45 ml. So I will take volume of solution to be 45 ml. Now what will be the concentration of the solution? That means in this 45 ml, 2 ml is present. So in 100 ml, how much is present? So 2 by 45 into 100. This much percentage by volume is the calculation. So whatever the answer will come, that much percentage by volume will be your answer. Now moving to the next leg of the session, that is saturated and unsaturated solution. So I think you people have come across these terms, saturated. Don't you say at times, I am totally saturated? Means you are totally tired. You have used up all your energy. So what does it mean as a solution? A solution is said to be saturated if you cannot dissolve any more solute in it at a particular temperature. So a solution in which no more solute can be dissolved at that temperature is known as saturated solution. Means maximum solute is dissolved at a particular temperature, say T degrees Celsius or Kelvin, whatever it is, but at a particular temperature, the maximum possible amount of solute is totally dissolved. That is known as saturated solution. Obviously, unsaturated means yet to be saturated, not yet saturated. That is known as unsaturated. But the temperature is remaining constant. The temperature is remaining T degrees Celsius or Kelvin, whatever. So a solution in which more quantity of solute can be dissolved without raising its temperature means, suppose the maximum amount of solute that can be dissolved is W2. Okay, and I have W1 over here. That means W1 can actually add on some factor to become W2. That means it is not yet, W1 is not the maximum capacity of the solution to hold on that much amount of the solute at a particular temperature. Okay, so at a fixed temperature, if the solution can dissolve even more of the solute, that means it is not yet saturated, and such a solution is known as unsaturated solution. When the temperature, at the same temperature, the maximum possible amount of the solute is dissolved, then it is known as saturated solution. See, let us actually go through some example. A maximum of 32 gram of potassium nitrate can be dissolved in 100 gram of water at a temperature 20 degrees Celsius. So what are all these conditions? Let us see these conditions once. Potassium nitrate. You know, potassium nitrate is KNO3. This is potassium nitrate. And they are telling that potassium nitrate is your solute. This is your solute. So I can say WB is equal to 32 gram, and this is the maximum mass of the solute that can be dissolved in, say, how much of the solution or how much of water. That is what? 100 gram of water. You can assume this solution made of water. So 100 gram of water may you can dissolve 32 gram of potassium nitrate, and the temperature to be kept at T is equal to 20 degrees Celsius. So since this is the maximum amount that can be dissolved in 100 gram of water to make the solution, so this amount 32 gram of potassium nitrate is actually the saturated solution of potassium nitrate. Again, another example for sodium chloride is given. It is said that the mass of sodium chloride that can be dissolved maximum is 36 gram when the mass of water is equal to 100 gram at 20 degrees Celsius. So what is the solubility, or what is the amount of sodium chloride required in order to make a saturated solution with water, or making an aqueous solution which is saturated at 20 degrees Celsius? That is 36 gram of NaCl. Okay. So next, what is the effect of heating and cooling on a saturated solution? Suppose the maximum possible amount that a solvent can hold is already being given. So the solution becomes saturated. Now, if a saturated solution, suppose I take a saturated solution, and to this saturated solution, I apply heat. Suppose I am heating this saturated solution. And at this point, what will happen is it becomes unsaturated. It becomes unsaturated. Why? Because when I am heating it, it is increasing the gap between the solvent particles due to the randomness of the solvent particles, and more of the solute can be dissolved in a fixed volume of the solvent when I am increasing the temperature. Now, similarly, if I decrease the temperature and I say minus heat, or I say I'm going to cool it, then what will happen? Then whichever solute was actually dissolved, it will crystallize and it will come out of the solution, and it will separate out to form solid crystal. That means to form a saturated solution, you have given the maximum possible capacity of the solute in a fixed mass of the solvent at a particular temperature. Now, when you decrease the temperature, as much I'll say capacity was there to hold the solute particles, now that capacity decreases because you are cooling it. The gaps are decreasing between the solvent particles. So that extra solute gets crystallized out, gets separated from the main bulk, and remains down as a solid crystal. Okay, so in this figure 42, you can see two beakers are there. One of the beaker is saturated solution, beaker A, and beaker B. What is happening in the right hand side? This saturated solution is being cooled. When it is being cooled, the particles of the sodium chloride is crystallizing out, is separating out from the main bulk of the solution. So next, moving on to solubility, which is very important point. This is solubility. What is the efficiency of the solution, or rather of the solute to get dissolved? So it's a maximum amount of solute which can be dissolved. Maximum amount of solute that can be dissolved in 100 gram of solvent at a particular temperature. That is known as solubility. That means you are specifying the solvent to be 100 gram. So 100 ग्राम में जितने सॉल्यूट डिसॉल्व होता है, जितने सॉल्यूट डिसॉल्व होगा, that is equal to its solubility. That is equal to its solubility. Suppose I say 32 gram of potassium nitrate was being dissolved at 100 gram of water. With 100 gram of water at 20 degrees Celsius. This we have seen before also. So the solubility of this salt, potassium nitrate, is 32 gram. But at what temperature? At a specific temperature. So at 20 degrees Celsius, the solubility is 32 gram. The solubility of potassium nitrate in water is 32 gram. Of course, it depends on the fact that in what solvent you are taking, number one. Number two, at what temperature you are taking. So it depends on these two factors also. So solubility of potassium nitrate in water at 20 degrees Celsius is 32 gram. That means 32 gram of potassium nitrate can be dissolved and is the maximum possible dissolution of potassium nitrate in 100 gram of water if the temperature condition is 20 degrees Celsius. Okay, so next let us see. At 20 degrees Celsius, these are the examples of different solutes dissolving, of course, per 100 gram of water, So according to the data, we can see that 37 gram of ammonium chloride and sugar 204 gram is getting dissolved at what? At 20 degrees Celsius. So at this temperature, sugar is having maximum solubility in 100 gram of water. So another question is given, 12 gram of potassium sulfate. Okay, 12 gram. Suppose potassium sulfate is the solute. So my WB is equal to 12 gram. Now you may think कि WB is equal to 12 gram. Now what is potassium sulfate? What is potassium sulfate? This is potassium sulfate means K2SO4. This is potassium sulfate. Dissolves in 75 gram of water. So WA is mass of water, that is 75 gram. The entire process takes place at 60 degrees Celsius. What is the solubility of this salt in water at that temperature? That means 100 gram of water. In 100 gram of water, how much of this potassium sulfate will dissolve if the temperature is 60 degrees Celsius? So it's plain unitary method. So I will say solubility of this K2SO4 in water at 60 degrees Celsius. So in 75 it is 12. So 12 by 75 into 100 will be this much gram at 60 degree Celsius. That is the solubility. Okay, so effect of temperature and pressure on solubility. Okay, so effect of temperature and pressure on solubility. Now it depends what you are taking, whether you are taking solid in liquid or you are taking gas in liquid. So if I assume that you are taking solid in liquid, then remember that with increase in temperature, the solubility of the solid in a given mass of the solvent is increasing. Solubility increases, and since solids are incompressible, so what happens that with pressure the solubility with pressure changes, increase or decrease. Solubility is unaffected. Why? Because solids are incompressible, so it actually is unaffected. Solubility of solid in liquid with pressure changes is unaffected. What about solubility of gases in liquid? So solubility of gas in liquid, you increase the temperature, the solubility will decrease because gas particles are free to move. They are always in random motion, and when you increase the temperature, the kinetic energy of the gas particles goes on increasing, and they will have a greater tendency to leave the surface of the solution and escape out. Thus the solubility decreases. Now, if I say gas and liquid, then if I increase the pressure, gases are highly compressible. So the solubility increases. Why it increases? Because gases are highly compressible. This is a tabular representation where we can see the solubility of copper sulfate at different temperatures is given, right? So at what temperature you can see the solubility is going maximum? So we see that if the temperature is increasing from 0 beginning till the end, that is 70 degrees Celsius, what is happening? The solubility is going on increasing, and obviously at the highest temperature the solubility is also maximum. Why? Because copper sulfate is a solid, and solubility of solids increases on increasing the temperature. So does it mean that this solubility will go on increasing infinitely? No, not at all. When at a particular temperature, you see that maximum possible solute is dissolved, after that you go to increase it, you will not be able to cause bring out any change. Okay, so see this question, a student determine the solubility of 4 substances. One is number 1 is potassium nitrate, that is KNO3. Number 2 is sodium chloride. Okay, so it is NaCl. Number 3 is potassium chloride. Potassium chloride is KCl. And ammonium chloride, number 4. So ammonium chloride is NH4Cl. These are the 4 things that are taken in water at 5 different temperatures. One is 10, next is 20, and then we can see it is 40, 60, 80. So these are the temperatures. Now the question says, first one, what mass of potassium nitrate would be needed to make a saturated solution of potassium nitrate in 50 gram of water at 40 degrees Celsius? So potassium nitrate 40 degrees Celsius, we are seeing there the solubility is given 62 gram. Now by the term solubility, we have defined what? By the term solubility, we understand this is the maximum possible solute that is dissolved in 100 gram of the solvent at a particular temperature. So the particular temperature is 40 degrees Celsius. So at 40 degrees Celsius, 100 gram of water can dissolve 62 gram. So if you have to find in 50 gram, that means half the mass of water, then obviously this will also become half the mass. So 62 by 2 is equal to 31 gram of potassium nitrate. Next, what would be observed if a saturated solution of potassium chloride at 80 degrees Celsius is left to cool? So we have already seen that when a saturated solution at a particular temperature is left to cool down, that means the temperature is gradually decreasing. What will happen? The particles of solute will separate out from the main solution because the solubility decreases at a lower temperature or decreases on cooling. What is the solubility of each salt at 20 degrees Celsius? So we'll find this parameter 20 degrees Celsius, and at this temperature, what is the solubility? That is already tabulated. We can see And which salt has the highest solubility at this temperature? 37 gram ammonium chloride as per the table. What is the effect of change of temperature on the solubility of a salt? Now, temperature means with increasing the temperature, the solubility of a salt in a particular liquid will increase. Why? Kinetic energy increases, the gap between the solvent particles increases, so more amount of solute can be dissolved.